The new manifest destiny is the exploration and colonization of the last and forever final frontier, space. Not only has it already begun, but if you've been subscribed to this channel, then you've been along for the ride in a front row seat in the orbiter. But in today's journey, we'll have our eyes glued to the celestial entities that might harbor life, and ones at the farthest reaches of space via NASA's James Webb Space Telescope, aka the JWST. Launched on Christmas Day of 2021, the JWST is already peering into the cosmos with a massive segmented mirror that stretches across an area the size of a tennis court. With its large beehive-shaped mirror, James Webb will soon be fully prepped to directly observe parts of space and time that astronomers have never seen before. Ranging from distant galaxies from the universe's infancy to asteroids hovering around the largest planet of the solar system, the telescope has a few high-priority targets on its list. And this marks our itinerary for today's presentation as we dive deep into the James Webb Space Telescope's top 5 cosmic targets. The Trojan Asteroids are two groups of rocky bodies that lead and follow Jupiter, and they may have been accompanying the giant planet for the past 4 billion years. The swarms of Trojan asteroids associated with Jupiter are thought to be remnants of the primordial material that formed the outer planets. According to NASA, the Trojan asteroids may have been dragged from all over the outer solar system during its early history billions of years ago, and have been trapped in these stable positions ever since. But similarly to most celestial entities in space, the Trojan asteroids are difficult to observe due to their distance and their low albedo, or ability to reflect light. The Trojans are stabilized by the Sun and its largest planet in a gravitational balancing act as they're clustered around the two Lagrange points equidistant from the Sun and Jupiter. Because the Trojan asteroids have special features observable in the wavelength that JWST can capture, Jonathan Lunine, chair of the Department of Astronomy at Cornell University, has high hopes that the Webb telescope will be able to provide information on where the asteroids came from and what role they played in Jupiter's formation. The chairman was quoted saying, "There's the opportunity potentially to get spectra of a number of those objects, particularly to see whether the ones that are in the front and the ones that are in the back, the Greeks and the Romans I guess, have some differences in composition that might show up at wavelengths that really have not been applied to those objects before." The JWST will also work in tandem with the upcoming Lucy mission to unlock the secrets of the Trojan asteroids. Let's be honest, the main drive for space exploration or huge investments in science in general revolves around gain. And although that statement might seem hyperbolic, knowledge is power, and this is what we crave as a species for the betterment of our species. Thus, space exploration and colonization are vital. Finding habitability in the solar system is not just confined to planets like Mars. It also extends to moons. In this regard, the icy moons of Saturn seem promising. Saturn's moon, Enceladus, has a subsurface ocean and plumes of water ice and vapor venting like an eruption from the moon's south polar region. With this liquid blasting from the surface, it's automatically on top of the list for alien entities able to host life. Jupiter's moon, Europa, has a vast ocean of liquid water, twice as large as the oceans on Earth. And its larger counterpart, Titan, hovering around Saturn, also has the potential for life with its methane and liquid water lakes and ocean deep below its surface. The JWST will investigate the plumes of Europa and Enceladus and their icy surfaces, along with their counterpart moon, Titan. Lunine believes Webb's observations of those objects are really more in the area of understanding those bodies as planetary objects. He went on to say, with Europa and Enceladus, we're very aware now that there's undersurface oceans. But what's in that ocean? That changes a lot about the composition and how we understand whether or not those feed into the building blocks of life. It is vital that we research near-Earth objects, also known as NEOs, for two crucial reasons. The first is to learn about the formation of the solar system, while the second is to defend Earth against potential impacts by these large objects. Christina Thomas, a researcher at the Planetary Science Institute at NASA's Goddard Space Flight Center, was quoted saying, "I'm really excited about the possibilities that open up here. We have various different things, from the objects that are close to Earth and all the way out to the Kuiper Belt objects. The Kuiper Belt is the same region of the solar system that contains Pluto. Planetary scientists believe the belt contains the leftover remains of the solar system's early formation, the same as the Trojan asteroids previously mentioned." Thomas went on to say, "We expect to see that the asteroids are going to look very different than the Kuiper Belt objects, and there's going to be a lot of really interesting comparison science here. So far, scientists have only observed a couple of objects from the Kuiper Belt, including Pluto. However, the JWST will observe these objects in the near-infrared and cover the wavelengths absorbed by Earth's atmosphere, therefore able to have a much better eye in the sky. Lunine, head of the Department of Astronomy over at Cornell University, illuminated more by stating, "It's been possible to do observations of large Kuiper Belt objects from Earth and by the Hubble telescope, but the Earth's atmosphere gets in the way of many wavelengths that are of interest, and Hubble has limited range in the near-infrared. The JWST has an overall mandate to find evidence of creation. To achieve that end, a map of the universe must be plotted, and the third most vital mandate is to find habitable planets. Fortunately, the JWST already has thousands of leads to achieve all three directives. Since verifying the first planets outside our solar system in 1992, astronomers have observed more than 4,000 other alien worlds around distant stars. And due to the numerous discoveries of NASA's Kepler mission and the Transiting Exoplanet Survey Satellite (TESS) missions, scientists will be able to get a closer look at these worlds. The JWST will study the atmosphere of exoplanets in greater detail to detect the ingredients necessary for life. It will have a high enough resolution to witness planets passing in front of their home star and draw out atmospheric properties when they transit. It only takes time and an awesome state-of-the-art space observatory. According to Thomas, we have a much larger mirror, which means that we can see much fainter things. There's a coronagraph on JWST that will be able to block the light from a central star so that you can actually try to probe a planet directly, which I think will be really exciting. First on the list of must-study exoplanets for the JWST is the exoplanet Trappist-1e. The exoplanet is located only 40 light-years away from Earth and virtually has the same size. On top of that, Trappist-1e orbits within its star's habitable zone, which is not too far nor too close for liquid water to exist on its surface. The scientists operating the JWST have planned 5 transit observations of Trappist-1e. As for the main obligation for the JWST, to peer back into the first light ever illuminated to understand creation, observing distant galaxies is vital. We now have the technology to see those galaxies that were once shielded by distance. As the universe expands, the further away a galaxy is, the faster it moves away from our view. The faster an object is moving away from us, the more light from that object shifts toward the red part of the spectrum. Chairman Lunine expounded, for the most distant galaxies that have been observed, that shift to the red is so large that in the case of Hubble, those galaxies have been shifted to wavelengths that are really at the far end of the red where Hubble can look, and even beyond that. The JWST has infrared capabilities that are able to look deeper at galaxies that are moving away from our view. Keep in mind, the further away scientists can observe, the earlier in the timeline of the universe is gazed upon, since light travels at a finite speed further back in time. Seeing that far back in time allows scientists to better understand how the first galaxies came to be and how they evolved. Lunine was quoted vouching for this fact by saying, "If you were an alien who came to Earth and showed up at a convention of scientists, you probably wouldn't see many babies there, so you would wonder what these creatures actually looked like when they were first born. And that would be an interesting question. We would like that same information for galaxies." Now that you're aware of the top 5 cosmic targets of the JWST and its 3 main mandates, excitement on what could be found should give you goosebumps, and you wouldn't be the only one. Thomas was quoted saying, "I am very excited and very much looking forward to the things that we're not going to expect. There have been so many great discoveries from various missions that NASA had been involved with over the years. And sometimes the greatest thing is that picture that totally blows your mind that is just completely unexpected." Luckily for you, Space Infinity will continue to monitor the cosmos via NASA and global space agencies and transmit those findings directly to your screen. All you need to do is hit that like button, subscribe, and share this video.